Dear participants, I welcome all of you in this lecture of data science using Python, where I will discuss certain projects based on data science. Sorry. And we'll see what are the different steps that need to be followed for any data science projects. So these are the steps for data science project. First, we need to get the data. So data could be, you know, anywhere on any open data set. Let's say you are getting the data from Kaggle, or you could say the data are available on different platforms, or the data need to be experimentally generated, right? So you can club with some other stream researcher, and you can get data from those researchers, right? So let's say you are collaborating with healthcare researchers, and they are having different type of data at their end. So you can get the data from those researchers. Then the next stage is dataset loading, right? So if you are utilizing Google Colab, let's say, and the next stage would be to load the dataset using Google Colab platform. Then we'll split the dataset on training and testing dataset. So we had seen in previous lectures, so how to split the dataset. Then we'll move on to pre-process the dataset. So pre-process would, pre-processing, it means you are going to handle class imbalance problem, or you could handle missing values, right? And similarly, you can scale your dataset. So it depends how your dataset is actually. So if you are having several missing values in your dataset, then you need to handle those cases. And if your dataset is having less number of records in any class, let's say there is a binary class classification type of problem, right? And one class is having very less number of records. So in pre-processing, you can handle those cases, right? Then after the pre-processing, we will select the model and train those models. Then finally fine tune your model so that your model can work, so that performance of your model can be enhanced. Then finally evaluate and present your solution. So these are certain stages of data science that we can utilize. So I will discuss here the very first project, and the task of that project is to diagnostically predict whether a patient has diabetes on the basis of a given data set. So you have been given a data set that is the diabetes prediction data set. We already discussed this data set. So on the basis of that data set, you need to predict whether a patient has diabetes or not, right? So that is the project number one actually. So as far as this project is concerned, so we will be utilizing PIMA Indians diabetes dataset. So this dataset originally from the National Institute of Diabetes and Digestive and Kidney Diseases, and the objective of the dataset is to diagnostically predict whether or not a patient has diabetes. And you can download this dataset. So link has been given here, and several thousands times this dataset has already been downloaded. So it's a very popular dataset, and it has been utilized in several data science and machine learning related problems. And this particular data set is having several features actually. So the data sets consist of several medical predictor which we call independent variable or features, and one target that is a dependent variable that we call that is mentioned as outcome. So we are having some independent variables and one dependent variable, that is outcome, and it is a binary classification type of problem, since it is having only 1 and 0 value as far as outcome is concerned. So either patient is having diabetes or not. So it is a binary classification type of problem. So all patients here are females and at least 21 years old. So we would visualize these detail as well. And total records are there are 768 records are there in this data set. So these are independent variables like pregnancies, glucose. So pregnancy is number of times pregnant. So it is having a record of a female only, right? So that's why there is a value of pregnancies. And then glucose level, glucose concentration value, blood pressure value, that is and then skin thickness, tricep skin fold thickness value, insulin 2-hour serum insulin, then body mass index value, diabetes pedigree function value, and then age. So these are independent variables. And dependent variable is actually outcome, which is a class variable 0 or 1, and 268 of 768 are 1, the others are 0. It means 500 entries are having zeros value and 268 are having ones values. It means the female who are having diabetes are having 266 records, right? So these are certain features of diabetes dataset. Let me switch to Google Colab, where we will execute all the stages of the data science, and there we will discuss certain step where we will discuss all the steps of the data science project. So first we need to do, first you need to import the data set, right? And before importing the data set, since I have uploaded my data set to my Google Drive, so first I need to mount the Google Drive, right? Let me mount this Google Drive so that I can access the data set which is there in my drive is already mounted, right? Since I was using this drive. Now if I would try to see the drive, so this one is the drive, Google Drive related to my account, this particular Google account, and these are files, right? My drive files like AB and classroom, Colab notebooks, data science using Python, and EvoluPy. So I am having all the data set here in this EvoluPy. So there are different folders and data set. So there are certain, I kept my data set here in this folder only, and it is there, yes, somewhere. Yeah, this one is the diabetes data set. Sorry. So this one is the diabetes data set. So I need to import this data set. So here I am reading the data set at this particular location. So switching to suppose you are having several folders in your Google Drive. So first you need to change your directory, right? I have changed my directory, like in this case, and then I am reading the data set. So let me read the data set. So this would be the very first stage to import the data set, right? So this data set has been imported. Now I would describe this data set. So I will get the basic information. So these are certain independent features, independent variables. So these are independent variables. So there are 1, 2, 3, 4, 5, 6, 7 and 8 independent variables and 1 dependent variables, right? And you can see there is no missing values in any feature, in any variable, since all are having 768 values. So there is no such uh, missing values. And I also describe this value. So total number of uh, records across different features are 768, right? And mean value is 3.84 in case of pregnancy. Similarly, the glucose level, the mean value is 120. Blood pressure level, the mean value is 69, and so on. So you can see here different values. And as far as age is concerned, so the mean of age is 33, right? So and the minimum and maximum value, so minimum value is 21 as far as age is concerned, and maximum value is 81, right? So these are description of the data set. Now the next stage of data science project would be visualization of data set. So here we will try to visualize and we will try to use different type of plots to visualize the data set, right? So here I am using histogram, right? And I am plotting glucose and BMI only in this case. I can take others as well. Let's say suppose I am considering, DF age. So age is let me see the age, yeah. So age, and here KD alpha 0. And I need to include one more color here. Let's say orange, right? So now I make it 0.5. Yeah, let me execute this one. So you can see here. So in this way it has been so age is also in this histogram plot, right? And I made KD as true. It means kernel density estimation is true. So that's why there is a KD graph also. So in this way you can plot your histogram. Now I want to print correlation matrix using the heat map. So I already told you in the previous lecture that the correlation matrix is actually used to display a relationship between between two features, right? So like in this case, the outcome and pregnancy, there is a relationship in terms of value, it is 0.22, right? So like in this case, the high value is having glucose level. So glucose has so much effect on diabetes, right? So that's why it is 0.47. So it has very high relationship, glucose. Similarly, the BMI level and pregnancies as well, it has significant relationship between pregnancy has significant relationship with outcome, right? So according to the values, we can see the correlation between different features. So this one is the correlation matrix actually. Now here I am trying to printing the Pairplot. It means plotting between between two features, how the values are varying between two variables. So it would take time, since it is trying to plot between two variables, right? So, and I have used hue, since I mentioned that hue is, we use this parameter for category only. So I'm using hue since outcome is having only zeros and ones. So you can see here 0, the blue color actually signifies that it is 0, it means no diabetes, and orange color is for diabetes. Now, so you can observe how pregnancies and age are having relationship, right? Similarly, you can observe glucose and age. So, glucose as age is increasing, so that is the value between almost 150 to 200. The high glucose level is uh, very prominent till age of 60, right? So till age of 60, glucose level is high till age of 60. You can observe it here, and where an orange color is actually for one where the diabetes, if where the patient is having diabetes. Similarly, you can observe different two feature, like in this case, this one is for BMI level and glucose level, right? So BMI level, you can see here, this orange is for uh, diabetes and this blue is for non-diabetes patient. So lower glucose value is, it means those patients are very low chances of diabetes, right? So by going through these plot, you can observe very patterns between two features and how they are actually related. Now, next I would split the data set into training and testing, right? So to split the data set, what we are doing here, we are first dropping the uh, dependent variable from this data frame, right? Since DF is my data frame, which is having diabetes data set. So now I would first drop this column, or you could say a dependent variable, right? And this would return, X would have the data set without the outcome variable, right? Since I am not using here, in place is equal to true. If I would be using in place is equal to true, then what would happen? This would be reflected in DF only, right? But actually, I want to create a separate data frame. So that's why I have not included in place is equal to true, right? And here, if in case of Y, I taken the output dependent variable only. So Y would contain value of all the patient having diabetes value as 0 or 1, right? So Y would contain the value of dependent variable. So this one is X and Y. So in this way, we have splitted the data set, right? Now, the next task would be to generate training data set and testing data set. And we are keeping the size of test data set as 20% and the training size would be 80%, right? So in this case, you can find X train and X test, Y train and Y test. So X train would have 80% of the data, right? And similarly, X test would be having 20% of the data. Y train would have 80% of the Y data set. And you can see here, there are certain values in this case, outcome, the Y train value, right? Similarly, you could observe Y test value as well, right? So in this way, we can split the data, right? I'm trying to create some empty data frame here that would be utilized later on, especially this data set, RES response. What I'm doing here, I have, I have implemented several models. and I want to store the performance of all the models into a separate file, right? And that separate file would have values such as accuracy, F1, uh, and recall, and so on. So this RES, this particular data frame would contain the performance of all the models, right? So that should be keep in mind. Now, the data pre-processing would be started here, and let me execute all these, right? So I'm executing this one. Now X and Y has been created here, and now X training and testing data set has been created now. Now handling imbalance. So I'm including data pre-processing here. The first one is to handle imbalance. So as far as handling class imbalance problem is concerned, we have seen random oversampler, random undersampler, right? Random what random oversampler will do? It would oversample the class which is having low records, right? And what random undersampler will do? It would sampling the class which is having largest number of records, right? So that is the purpose of random oversampler and random undersampler, right? Similarly, there is one other option that is called SMOT. SMOT is also used to oversample the data set, right? So this one is the handling class imbalance. Now there is one more pre-processing stage which is called data scaling, right? And for that purpose, I am using a standard scaler, right? So it would scale the data set, and next I'm not executing these two, right? First I will execute the models without pre-processing. Then later on I would execute the models, and we'll see the difference in results, right? So as of now, I'm not executing these two stages, these two options, handling class imbalance and data scaling. Now I would import modules for performance metrics like precision score, and then accuracy, F1 score, recall, ROC curve, and then several others. I would also try to display the confusion matrix. Now the first one is logistic regression model, right? So what I'm doing here, I'm taking copies of the actual training and testing data frames. I'm just taking a copies of all these, so that the actual data frame should not be disturbed, right? So in this case, now I'm creating an object of logistic regression, and this is not useful in this case. So I'm fitting that model, that is logistic regression model, and here I would get the predicted value, right? So it would give me the predicted value, and after that I'm finding the precision score, and then accuracy score, F1 score, recall score, and as far as ROC curve is concerned, so ROC is receiver operating characteristic curve. So ROC stands for receiver operating characteristic curve. So for that purpose, I need to have false positive rate and true positive rate. I need to find out false positive rate, and you could see here. So this RSC curve function method would return several values, which is false positive rate and true positive rates, and as well as thresholds. So what actually RSC curve does, it actually draw a curve on different thresholds. It actually draw a curve of false positive rate and true positive rate based on different thresholds. So that curve is actually RSE curve. Now here at this stage I am trying to store different performance matrices, the value of different performance matrices in this data frame, right, in RES data frame under logistic regression column. So it would similarly later on I would execute the random forest and I would store performance value under a random forest. Now I am trying to get the confusion matrix, and here confusion matrix would be displayed, right, and these plot title is to display the logistic regression title, right. Let me execute this one. So it has been executed here. So you can see this one is the confusion matrix of this logistic regression. Yes. So 37 it actually says it's a true positive value, truly predicted value, that is 37, and true negative is 78, truly predicted negative, true negative. And this one is this one is the predicted value and this one is the true value. So it's falsely this value is a falsely predicted negative, false negative, right. False negative is 18 and this one is the false positive. This one is 21 is false positive. False positive, it means your model has falsely predicted positive, right. Actually it was negative, but your models has falsely predicted positive, this particular in this particular model. Now the next one is decision tree, which is all the steps are very similar except the name of the model, right. All the steps would be very much similar. Let me execute this one also. So you can see here it has this decision tree. In case of decision tree, the true positive is 40 and true negative is 77, right. Similarly, random forest classifier, you can execute this one. Let me execute this one. And in each and every model, I am storing the performance matrix value. So all the score, that is precision, accuracy, F1, it is being stored in this data frame. And finally, at last, I would write this value to a particular file, right. So similarly, I am executing this one, random forest. I have also implemented the model KNN, very similar. I mean, all the steps would remain similar. KNN, and then Naive Bayes. I have taken Naive Bayes model as well, and gradient boosting model. Why I have taken so many models? So that we can compare the models, that which model has given higher accuracy and recall and so on. Now, here in this case, I am also trying to display the ROC curve. Let me first execute this one. So, you would observe the result here. So, this one is the ROC curve. So, ROC is actually receiver operating characteristic curve, right. So, what it does, it actually display the value of false positive rate and true positive rate at different thresholds. So in this I am trying to display the curve for each and every the result that has been generated by each and every models, right, decision tree. So this is the area actually says this area, I mean the value from this one is the area. Similarly, each model is having its own area. So the higher the area is, the the good the model is actually. So the model which is having high area is actually good model in this case for this particular data set, right? So how I have displayed this ROC curve? So I'm using the matplotlib plot method. So in this case, here it is false positive rate of decision tree, true positive rate of decision tree. I have already told you the ROC curve actually plot false positive rate and true positive rate at different threshold. Now the color I have taken color as red, and line width, LW stand for line width, which is 2, and then label that has been displayed here. So label is actually these are labels, decision tree, random forest, and so on. So label is decision tree, and area, it means how much area it would take, right? So not how much area, actually the value of area, this area is 0.753. So 0.33 is actually the number of digits after the decimal. So 3 digits would be there after the decimal, and corresponding to this percentage, the value would be displayed. The value of ROC decision tree ROC under area under curve would be displayed. So this is the meaning of different parameters inside the plot method. Similarly, for each and every model, I have used these values, right? So that's why this value have been displayed here. Area is equal to 0.753. Similarly, for random forest, area is equal to 0.707, and so on. Now there is one more like plot. Here I am using 2 different lists. So the purpose of list is to display this line, the middle line, and middle line, for the to draw this middle line, I need to have 2 points, right, which is 0, 0 and then 1, 1, right? This point is 1, 1. And how it actually takes the value? It takes the value of all x. So my x is 0, and the next x value of next point is 1. Similarly, this is all y's, right? So value of y of very first point, value of y of second point, right? And then color indigo and so on. So in this way it has been displayed. Legend is equal to 0. It means where you want to display the legend. Let me write this one, right? 1. If I would write 1, so here as of now the legend has been displayed here at bottom right. Let me execute this one. So now the legend would be in this manner, top right. Similarly, you can move these legend. Now it has been moved to left side. It has moved to left side. So top left. So this is the purpose of legend, and this is xlim is actually value of this one to display a line from x limitation of x and y limitation. It means this is my boundaries, actually boundaries of my plot. So the boundaries of my plot, the x value is 0 and 1. So x value is 0 and there is 1, right? Similarly, y value of this boundary is 0 and 1. So in this way we have set the boundaries, and then x label is false positive rate, which is this value, and y label, which is true positive rate, and the title is ROC curve, which is displayed here. So in this way you can display the ROC curve. Now here I am actually storing the response of my feature matrices of my different models, right? So here it would store the scores of different scores of each and every model. Let me execute this one. Now I am going to open that CSV file, which is swam_project_result_scaling. right? So let me open this one. This file is somewhere. Let me write some different name. Actually, it's not a scaling. I have not used scaling option. So now I am executing this one. So a new file has been created, which is swam_project_results. Let me look that file. So that file is inside develop_i, and here I can see. Let me search this file. So swam project results, right? This one. Let me so these are values. So decision tree is having accuracy as 75.97, and logistic regression has value accuracy as 74. Similarly, random forest has accuracy as 72. So among all, decision tree has shown good performance, right? Not decision tree, naive Bayes. Yes, naive Bayes has highest accuracy as far as uh, this data set is concerned. So naive Bayes, and these naive Bayes are actually ensemble type of model. So it has given highest accuracy. But other scores like precision, what about precision? So decision tree is 64, and the highest precision is 66, naive Bayes. So overall, naive Bayes is giving good performance, right? So now what I am doing here, now I will perform the pre-processing stage and will try to look the results now. So I will write and I will store the scores in some different file. Now I am trying to execute. So let me execute this one. If I want to, execute all the cells after this cell, so what I will use run after. So what actually run after does, it would execute all the cell after this particular cell, run after, right? So all the cell would be executed, right? So all the cell would be executed. So this Pairplot will actually take some time, since plot of every two features would be displayed. So that's why it would take some time, and the rest step would be in quick time. So it is being generated here. Pairplot would be generated here. So we'll try to observe the difference, right? So it has all the steps have been executed now. So all the steps have been executed. All right. Now the results of this after pre-processing have been stored in scaling. Let me open that file also. So where the file is, yes. So this one is the without pre-processing. This file is without pre-processing, and this file is with pre-processing. And I am going to compare both. Oh, sorry. Yes, I am going to compare both these. So this one is the scaled result. So you can observe scaling has boosted the performance of decision tree. You can observe, in this case without scaling, and so here we have used two different options under pre-processing. The very first was oversampling, right? Feature scaling, and the next one was of sorry. The first one, let me see what we have used. So we have used scaling and handling class imbalance, right? So we scale the data as well as we handle the class imbalance problems. So this pre-processing has given some better result as far as decision tree is concerned, right? Similarly, random forest performance has also improved here. And what about the naive Bayes? Yes. So naive Bayes, as far as naive Bayes is concerned, so naive Bayes remains same. So it has not affected the naive Bayes, but other decision tree, other models have improved, right? Now you can observe, you can apply different type of pre-processing activities and see the results, how actually your pre-processing activity has improved the results, right? Now I am stopping here. So these are the stages that you need to perform to solve any data science type of problem. Thank you so much for joining the session. We'll meet again in next lecture with some different type of data science related project.